This video focuses on the landforms that we find along the course of a river, and there's a little blue box in the top corner of each of these slides which tells you whereabouts along the river course we find these landforms and whether they're formed by erosion, deposition or a combination of the two. So starting off with waterfalls at the top of the river in the upper course, and they're formed by erosion. And they are created when we get bands of harder and softer rock sitting next to each other on the bed of the river. And the river erodes the softer rock more quickly. It's hydraulic action and abrasion that are mostly doing this. And that starts to create a step in the river where that softer rock has been eroded away. The softer rock beneath the harder rock as well gets eroded away, and what we get then is this overhang being created, and the diagram there illustrates that to you. That darker grey, that pale grey rock is the harder rock that's more resistant and has stayed in place, and the softer rock that's beneath it is starting to erode away more quickly, and so we get this big piece of overhanging resistant rock. That starts to create this large drop, and the force of the water coming down over the harder rock causes erosion of the riverbed beneath it. And the higher that drop becomes, the further it erodes away, the more energy that water has, and so it's continuing to erode the riverbed. We also get a plunge pool created underneath, and that's created mostly by abrasion. So rock that's come off that overhang or that's eroded away from underneath is sitting in that plunge pool. The water is kind of churning round in a circular movement, and all of that sediment is getting dragged along and eroding the riverbed beneath the drop, creating this sort of round, deep plunge pool where the water falls down. Next up, we have a gorge, again in the upper course and again caused by erosion, and these are linked to waterfalls, so you may get an exam question asking you about how gorges are formed. The first part of that process is a waterfall is formed. The plunge pool continues getting larger due to erosion, and the hard rock that was sticking out there that we saw in the diagram on the previous slide slowly begins to retreat over time. So it's more resistant than the soft rock, but it's not entirely resistant to erosion, it's just eroding more slowly. And as it erodes and moves backwards, what we get left behind are two very steep-sided valley walls, and we call those a gorge. So a gorge essentially is formed as a waterfall retreats over time. And the final landform that we need to learn about in terms of the upper course of the river, also caused by erosion. That's because we have a lot of erosion happening in the upper course of the river. It's what we call a V-shaped valley. So this has a very deep base, as erosion is pushing down in a vertical manner, eroding the riverbed. Again, it's mainly abrasion and hydraulic action that are doing this. We get what are called interlocking spurs. So you kind of see, as you can see in the little diagram, how the sides of the slopes are kind of overlapping one another. The river is sort of meandering through these interlocking spurs, and that just happens where you've got rock of different kinds of resistance. So the harder rock stays in place for longer than the softer rock, and the river is essentially finding the quickest and easiest way through. The top of the valley becomes very wide, and that's because we have lots of weathering happening at the top. So the upper course of the river tends to be very high or higher altitudes, and we get more colder temperatures and more rain in these parts of the country. And so we get more freeze-thaw weathering, where the temperature dips below zero overnight and then comes back up above freezing in the daytime. And yeah, lots more rain, lots more exposure to the elements, which means that rocks are breaking off essentially at the top of that valley, moving down the steep slopes. We have mass movement like rockfall that's bringing that rock down, moving that material and creating that really wide top. So we're now moving on to the middle course of the river, and we're looking at meanders, which are caused by both erosion and deposition. And these are these big windy bends that we find in the river at this point. They form as water flows over areas of different depths, and where it gets slightly more shallow, the water starts to slow down. As it goes over a deeper part, it gets faster again, and the difference in speed creates something that we call a helicoidal flow. So essentially it's kind of a circular spiral flow within the river, and that corkscrews, that moves from one side of the river to the other, and we believe that's what starts to cause the process of meanders forming. So on the outside of the bend, the water is flowing faster, it's moving around quickly, and that's causing lateral erosion. So that's erosion to the side, and that's undercutting the riverbank, creating what we call a river cliff. So if you have a look at the little diagram just above where I'm speaking now, you can see on the left of that diagram, you've got that river cliff being formed. It's being undercut by the speed of the river coming through, so erosion happening on that side. On the opposing side, on the inside of the bend, the river is flowing more slowly. That's because there's more friction, because it's more shallow, and that results in more deposition happening, and that's where we get this slip-off slope, or sometimes called a river beach. So essentially that meander, you can see from above, it's got that sort of sinuous shape, and then you've got the little cross-section diagram there, which shows you that actually it's deeper on the outside and shallower on the inside of the bend. And then linked to our meanders, our second landform we look at in the middle course of the river is an Oxbow Lake, and this is formed by erosion. So what we have over time are those meanders becoming more and more sinuous and larger, and then over time we find there's only a very narrow strip separating the river channel. So where those meanders are really bending round, and you can see that the kind of second picture in that little diagram kind of starts to illustrate how that gap is getting smaller and smaller. Erosion of the two outside bends continues until the water cuts through the narrow strip. So that's the third diagram that you can see there. And the water is finding the fastest route. And so the loop of the old channel becomes more and more detached from the main river, and that kind of stays in situ as a kind of marshy lake. Over time it may eventually dry up, but the river channel now is moving in that straight position. And we find this isn't something that happens very quickly, but we might have sort of flood events which are pushing water over the banks of the river and starting to kind of cut through that neck of the meander to create that different direction for the river channel. And then the Oxbow Lake is what's left behind, is that horseshoe-shaped marshy lake that we have left behind. So we now move on to the lower course of the river, and our final two landforms, the first of which are floodplains, and these are caused by deposition. So you'll notice lots of erosion happening in the upper course of the river. We've got erosion and deposition happening in the middle course, and then the landforms in the lower course are mostly caused by deposition. So a floodplain is quite simply the area of the river, either side of the river channel, where the water extends to when there is a flood event. When the river floods, it's not just water that's coming out of the river channel, it's sediment within that water that is taken out, and energy is lost very quickly because it's going from that deep river channel out into the shallow floodplains, and so the sediment it's carrying is often deposited. And so as floods happen and keep reoccurring, the floodplain becomes higher and higher, but also the land becomes more and more fertile. So over hundreds of years that floodplain builds up, and that land very often is great for farming, for agriculture, for growing crops. Though obviously you've got flooding to contend with, so that to think about as well. And our final landform is a levee, and this is again lower course. This is again caused by deposition, and this links to our floodplains. So it's something that's found right on the edges of the river channel, and they can kind of extend across into the floodplain. So when a river bursts its banks, we have friction with the land. So again, the water was in this deeper river channel. The friction with the land as it moves out of that river channel reduces its velocity and it causes deposition. It loses energy and it drops the sediment that it's carrying. The heaviest sediment is dropped first, and that's dropped closest to the river, and then the size of material deposited gets smaller the further away you move from the river. And so with each successive flood, the banks of the river, these levees, get built up higher and higher. However, the thing you need to watch out for is that the capacity of the river doesn't necessarily increase, because the bed of the river is also having sediment laid down over time, and that raises the river in the channel. And so as the flooding continues to happen, the capacity of the river channel itself doesn't necessarily increase, although these levees on each side of the river bank, will be building up over time next to the floodplain.